Yes, Gayana, I hope you are able to hear me. Confirm by saying yes.
Yes, sir.
Yes, Sarvanaram, you are able to hear me? No, your mic has some problem. I am unable to hear you, Sarvanaram. Please check. Indumati, am I audible?
Yes, sir.
Shri Krishna, what about you?
Yes, sir.
Shakti Varshini,
Yes, sir.
Shrish, Shoaib, Kashika, Menaja. Confirm whether you are able to hear me or not.
Yes, sir. Yes, sir.
Yes, sir.
Okay. Lohita Shri, Kirtana Rajashekar, Lakshita, Kirtana. Confirm your
Yes,
presence.
sir. Yes, sir.
Okay. So, what about Karthikeyan, Soumya, Shakti Varshini?
Sir.
Shakti Varshini, you are able to hear me?
Yes, sir.
Okay. What about you, Sarvanaram? Can you say something now? Say something. Your mic is muted. Can you unmute and say something? No, your mic has some problem. You can reconnect, check your connection. Kirtish Kumar, you are able to hear me?
Yes, sir. Sure, sir.
Okay, good. So, I think everybody except Sarvanaram is able to hear me. Muhammad Arshad, are you able to hear me?
Yes, sir.
Okay. So, let us start today's class. Right. Give me a second. Yeah. Yes, sir. Sarvanaram, I think your mic is not working. But whatever, let us start the class. We are already a little late. So, I think in the last class we have finished rotational mechanics, system of particles and rigid bodies, and today we are going to start a completely new chapter. All of you please give the heading as gravitation. Today we are going to start gravitation. Simple, easy, interesting chapter, but obviously it will need some inputs from vectors. If you are not knowing vectors properly, you may have a tough time today. Anyhow, I will recall everything while I am teaching, but if you are not knowing vectors, then you will have some difficulty in understanding today's class, because this topic is based upon that. First of all, as I always ask, once again I am asking, what do you mean by gravitation? Tarun, you are Tarun, right? Yeah, what is gravitation? Whatever you know. Force acting on? Force acting towards the earth. Okay. Sadhana, what is your opinion about gravitation? Force. Okay. What is your opinion, Raghav? Attractive force acting between the earth and every other particle. Okay. What is your opinion? Objects attracted towards the earth. Okay. Lohita Shri, what is your opinion about gravitation? Whatever. Yeah.
It is a pull, sir, towards gravity, towards the ground.
Gravitation is a pull towards the gravity.
Towards the ground.
Towards the?
Can I try, sir?
Yes, you can try, please.
Sir, it's a force that pulls any object towards the center of the earth.
It is the force that moves any object towards center of the earth. Okay, good. Soumya, what is your opinion about gravitation? Yes, what is gravitation as per you? Whatever you know, right or wrong is secondary.
Pulls the object down the earth.
Force that pulls the object down the earth. Raitanya, on your camera and give me some opinion about gravitation. Make it fast.
Sir, I guess that it is a force of attraction between the earth and the objects.
Between the earth and the objects. Okay. Now, last is Indumati. You give some reply of yours.
Sir, is the force of attraction between two objects, sir.
Okay, force of attraction between two objects. It can be any two objects.
Yes, sir.
Okay.
Gravitation can be any.
Okay. Kirtish Kumar, what is gravitation?
Sir, I can say that any mass that creates a force of attraction, that is gravitation, or even I can say that the gravitation is created by energy.
By
Energy.
energy. Okay, coming back. So with listening to most of you how you spoke about gravitation, one thing is clear, you are having less idea about the difference between gravitation and gravitational force. They are not same. Gravitation is a property. Gravitational force is obviously a force. Gravitation is a property by which two objects, any two objects on the earth, inside the earth, outside the earth, anywhere in the observable universe, anything that you see, anything that you know, any two objects are always having some attraction towards itself, towards each other. That property is called as gravitation. Whereas gravitational force is the force with which two objects are getting attracted. Once again, I want to say this, when you hear the word gravity, you start relating gravity with earth, because you are feeling earth's gravity. But every celestial object, every object is having gravitation. Even this bottle is having its own gravitational field. You may have a doubt, if it is having its gravitational field, then why it is not attracting things towards itself. I will tell about that later. Today we will learn that also. But remember that every object in the universe, every object has tendency to get attracted by any other object. That force of attraction is directly proportional to product of their masses. These things are Newton's law of gravitation. But first understand what is gravitation. Write a definition. It is a property by which two objects attract each other. Gravitation is a property by which two objects attract each other. Gravitation is a property by which two objects attract each other. Two objects attract each other. Then first you write Newton's law of gravitation. The first topic in this chapter is Newton's law. Newton's law of gravitation. Okay. So pay attention, I will give time for writing. Menaja and Shakti Varshini, video should never go off, remember that. Okay, coming back. So if there are two objects, let me assume one object has a mass m1, another object has a mass m2, and center to center distance between them is r. See, whenever I talk about distance between two objects, I neither talk about the internal distance nor I talk about the far distance. I always talk about center to center distance. Okay? So now we are talking about this force that acts between these two centers. So as per the Newton's law, every two objects will attract each other, and this force of attraction is going to be proportional to product of their masses and going to be inversely proportional to square of distance between them. That is what is Newton's law of gravitation, which says that every two objects in the universe attract each other with a force which is proportional to product of their masses and inversely proportional to square of distance between them. When I combine both, I get F proportional to m1 m2 by r square. When I remove proportionality, I have to add a constant. That constant is called as universal gravitational constant. This capital G is called as universal gravitational constant. What is the meaning of that? This constant, why it is called as universal? Because throughout the universe its value will not change. See, very similar to this force, gravitational force, we have another force called as electrostatic force. about which you will learn in 12th standard. There when I write F, it will be proportional to Q1, Q2, inversely proportional to R square, but when I remove proportionality, I will add a constant there. That constant will be medium dependent constant. It means if two charges are kept in air, if two charges are kept in water, in alcohol, in spirit, in oil or in any other medium, the force between them will change. Which force? Electrostatic force. But gravitation force between two objects will never change because of change in medium. It is same throughout the universe, and that's why it is called as universal gravitational constant. Its value is 6.67 times 10 to the power minus 11 Newton meter square kg power minus 2. This is the value of capital G. So, this is called as Newton's law of gravitation, which gives us the force of attraction between any two masses, and the formula is F is equal to G m1 m2 by r square. I think most of you will already know this from your 9th standard. It is not new to you, it must be known to you. So, copy it up fast. Write the statement first of Newton's law of gravitation. Statement is every two object in the universe, every two object in the universe attract each other. Every two object in the universe attract each other with a force. That is directly proportional to their masses. And inversely proportional to square of distance between them. Then you can write this thing. What is there on the board? Copy it up fast. Kirtana Rajashekar, please make sure a video is on here. I should not say it every time. Video should be on.
Sir, 5 minutes, sir. My network is not able to.
Make it fast. If you're joining for online class, you're expected to have video always on. Have you copied it? Okay. Everybody copied? I hope you have copied. If yes, I will proceed further. Shall I? Okay. Now pay attention. Looks very simple. But don't expect in the examination M1 is given, M2 is given, R is given, get the answer. It will never happen like that, because you are not in 9th standard. Mass of Earth is so and so, mass of Jupiter is so and so. What is the force of attraction between Mars and Jupiter if the distance between them is this much? It will not come in the examination. It will not come. What will come then? See here. If you have one mass, you have another mass, and you have third mass. Okay? I am having mass of 1 kg each, kept on 3 vertices of an equilateral triangle having 1 meter side. Is it clear what I have told now? We have 3 masses, each having a magnitude of 1 kg. Where they are lying? On the vertices of an equilateral triangle. what is the net force on the mass kept at A? What is the net force on mass kept at A? What will be the answer? How will you solve it? Now 50% of you will leave this question. If I would have given you, if in the same question, I would have removed this. Question becomes simple, right? 1 kg, 1 kg, 1 meter. What you will do? F is equal to G into 1 by 1 square. G is the answer. That is 6.67 10 to the power minus 11 Newton is the force of attraction between them. Are you getting my point? But unfortunately, question is like this. Now what will you do? Your name is Niharika, if I am right. Tell me, what will you do? Just give me your opinion. How will you find net force at A? No idea. You will leave this question. If the question comes today, exam is there, 10 marks. You will leave it. What you, some try you will give, no? It can be wrong also. What will you try? Form of substitution, which you will take? M1, M2, R. This you will take. At A, what will you take? Formula is F is equal to G M1 M2 by R square. Good. What will you put for M1? What will you put for M2? What will you put for R? 1, 1, 1. Okay. Then whatever answer you get, that will be the answer. That's what you will do. Okay. What will you do, Sai Varshini? Okay. So what you will do, Varshini, is you will find these two objects, one force. These two objects, one force. These two objects, one force. Add all three. Subtract all three. Or leave as it is. Add all three. Okay, no problem. That's what you will do. Subtract what? Add all and subtract what? Don't overthink. Okay, fine. What is your opinion, Pritish? What you will do if the same question comes?
Me?
Kritish, not you. I will come back to you. Pritish, what is your opinion? Yes.
First I will find for A and B,
Okay.
B and C.
Okay.
C and A, and I'll add them.
C and A and C and C and A will be same. Anyhow, so you will find these three and you will add them, right? Okay.
Yes.
Kritish Kumar, what is your opinion?
சார் நான் வந்து இந்த ஏக்கும் பிக்கும் போன போஸ்ட் கண்டுபிடிச்சி அப்புறம்
Correct?
சாரி மூணு ஆப்ஜெக்ட்டுக்கும் போஸ்ட் கண்டுபிடிச்சி எல்லாத்தையும் மல்டிப்ளை பண்ண ஆன்சர் கிடைக்கும்னு தோணுது சார்.
Multiply panna. It means F1, F2, F3, net force will be F1 into F2 into F3. அப்படியா?
எஸ் சார், மல்டிப்ளை பண்ணி டிவைட் பண்ணா 5.
மல்டிப்ளை பண்ணி என்ன டிவைட் பண்ணணும் தம்பி?
ஒவ்வொரு ஆப்ஜெக்ட்டுக்கும் இருக்கிற ஃபோர்ஸை மல்டிப்ளை பண்ணி டிவைட் பண்ணலாமே சார்.
Okay, we'll come back to you. Think for a little bit more.
Okay.
What is your opinion, Shoaib? Yes, Shrish, I'll come back to you. Give me a second. Shoaib Ahmed, you try.
And add all the forces and that's it.
That is FAB, FBC, FAC and add all three, right?
Yes, sir.
Okay, fine. Shrish, come on. Something you are about to say.
Since it is an equilateral triangle, angle between AB and AC is 60 degrees. So first finding force of AB, then between AC, and then if we do use vector sum of addition, we can find, sir.
That's all. He is right. He thought it. You forgot, I told in the beginning of today's class, vectors are very important for this chapter. What we will do, they are asking us to find, everybody pay attention please. Gayana, if you have stopped talking to the people nearby you, please focus here. So, if we want to find the net force on A, what we are going to do? We are going to find the force between A and B, right? Attractive force. Then the force of attraction between A and C, isn't it? How much will be FAB? FAB will become equal to G into 1 by 1 square. That is going to be G only. Same way, FAC is also going to be G only, 1 into 1 by 1 square. I got FAB, I got FBC. You know very well, if there are two vector quantities acting like this and the angle between them is some 60 degree, the net component will be somewhere here, and what will be its value? If it is FA and if it is FB, net force will be root of FA square plus FB square plus 2 FA FB cos theta, isn't it? Isn't it? That's what you will do. After that, what is it? This is the answer. Net force is this, F net. What will be that? F net in this case will become equal to root of G square plus G square plus 2G square cos 60. What is cos 60? 1 by 2. So, root of G square plus G square plus G square. Am I right? Because 2 and 2 will get cancelled. We are going to have root of 3G square, and the answer is net force is equal to what? Root 3G. Put the value of G, you will get the answer. Did you understand this? What did we use now? We used vector laws of addition. Isn't it? We have two forces, one acting here, one acting here. You found a net force. We don't have to bother about FBC, Sai Varshini. Why you want to think about FBC itself? They are not asked about FB or FC. They are just asking about net force on A. Then why we will bother about what is the force between B and C? No, never matters. Are you getting my point? That is how the questions are going to come in the higher classes, based upon vectors of forces, not directly the forces. Force is a vector quantity. So, all the addition must be done by using vector laws only. You told I will find FAB, FAC, FBC, add everything. It is not scalar, it is vector. You cannot do scalar addition on force. You must do only vector addition. If anybody has doubt, ask me. If there is no doubt, write the answer first. If anybody has any doubt, feel free to ask me how it has come. If you have no doubt, proceed. Copy this, I will give another question. Copy this, I will give another question. Everybody please. I hope you have copied. Can I give next question? Shall I? Okay, I will wait for a minute. Make it fast. I hope you have copied. Shall I proceed? Take another question. Similar question. Question is, there are three masses once again, but this time the angle is not equilateral triangle, okay? It is right angle triangle. Here is the mass 2 kg, here is the mass 3 kg, here is the mass, how much you want to take? 5 kg, take 5 kg, okay? They have given 3 meter, this is 5 meter, okay? And now they are asking you to find what is the net force on 5 kg mass. What is the net force on 5 kg mass? Make it fast. What is the net force on 5 kg mass? Give a try fast. Let me know if you have got any answer. Tell me. Obviously, force means you should be vector laws only. No? Force came, then how we can solve without vector laws? Zero, maybe, I don't know, we'll check. Anybody else? Raghav says the answer is 0. Anybody else who has any other answer?
Sir, is the answer approximately 5G?
5G.
Yes, sir.
Let us check that. Anybody else? Any answer? Shrish says it is 5G. Let me check. If anybody else has some other answer, you can tell me, or else I'll solve. Since they are asking us to find the force on 5 kg mass, this 5 kg will be attracted by this 5 kg will be attracted by this also. This force, I am taking it as F1, this force is F2. So, what is the value of F1? G into 5 into 3 by what square? It will become 4 meter, right? If it is 5, it is 3, it will become 4. Root of 25 minus 9, root 16 is 4. So, 4 means 4 square. What will be F2? F2 will become equal to G into 5. You made a mistake. Okay, let us check. divided by 3 square. So here you are going to get F1 as 15g by 16. Here you are going to get 10g by 9. Do you agree? We got F1, F2 value. Net force will become equal to root of F1 square plus F2 square plus 2 F1, F2. What is the angle between them here? 90 degree. What is cos 90? 0. This term will get cancelled. So F will become equal to root of 15g by 16 plus 10g by good square of that. After that, you solve and get the answer. I don't want to solve further.
Sir, I said 1.44 G, sir.
Maybe. I think that is the answer. If you solve, you will get 1.44 G. If you are getting that, it is correct. But the way of solving is more important than the answer. If you are understanding how I am solving, then you are able to relate the concept of gravitation with vectors. Gravitation is simple, but when gravitation is mixing with vectors, it becomes a little complicated. And now I am solving only 3 body diagram. Imagine you have an object like this, and then I will ask you to find the net force on a particular mass. Then you have to find 3 forces like this one, this one, this one. First you will resolve this and find the net force, and then net force in this will be added, total force you will get. Are you getting my point? That kind of questions can also be asked. If you have 4 masses and if I ask you find the net force on this mass, then what you will do? These 2 masses will have a force, I am taking it as F1. These 2 masses will have a force, I am taking it as F2. These 2 masses will have a force, I am taking F3. First we will resolve F1 and F2. It will be resolved in the direction of F3 only, isn't it? Suppose I am writing it as F12. So F12 plus F3 will give the answer to you, isn't it? This much level of question can come in school level itself. Krishna, you want to go to waiting room? I hope you are getting my point. So how this kind of question has to be solved, is everybody clear in that? Is everybody clear in that? 1 minute, man. First of all, I told you to come offline class. Once again you started coming online class. In online class you are offing your video and sitting. I don't know.
Sir, just now, sir, I got disconnected, sir.
Okay, man. There is no excuse accepted. If you have problems in online class, come for offline. If you are attending online, you have to be very clear in that. Please, Krishna, it's not about any kind of argument. It's about your future. It's about your understanding, your learning and your exams results, everything. Please pay attention. Coming back. So I think everybody understands this. Is it clear to everybody now? So what is Newton's law of gravitation and how the Newton's law of gravitation questions are going to come in the exam? Is it clear to you? Shall I proceed further? Okay. Now give the heading as acceleration due to gravity. Acceleration due to gravity. Those who are there in the bridge course in the beginning of 11th, for them I have taught all these things already. For them it is a revision if you are remembering that. Anyhow, let us learn once again. So what is the meaning of acceleration due to gravity? It is denoted by small g and has a fixed value of 9.81 meter per second square. Am I right? Generally we are taking it as 10, though it is not good, but we are doing that. You may think what is the problem, 9 and 10, same only, but it has a great difference in the macroscopic level. But fine, anyhow, we are rounding it off. Whether this value which we are assuming always as a constant, whenever g comes put 10, whenever g comes put 10, right? Up to now that only we are doing. Whether it is really a constant, we will learn about that today. As you said, yes, it is not a constant. On what factor it varies? We will learn about those factors: height, depth, Earth's rotation, Earth's size, that is shape of the Earth. Many factors are there. We will talk about that. But before we talk about that, let us understand what is the meaning of acceleration due to gravity. So we know that if any object is there, it will have its own force of gravitation by which it attracts object towards itself. Same way like how we are getting attracted towards Earth, if I go on Mars, I will also get attracted by the Mars. If I go on Moon, I will also get attracted by a Moon. Whichever celestial body I go, I will get some attraction by that body. But the attractive force may not be always same. For some case it will be too high attractive force, for some cases it will be low attractive force. Like Moon, if you go, you have less attractive force. Mars, if you go, you will have less than Earth. Like that, each planet, if you are landing, each celestial body you are landing, the force by which you are getting attracted will not be same, it will be different, isn't it? If the force is going to be different, obviously the acceleration by which you are pulled towards itself is also going to be different. So, first thing, what is the meaning of acceleration due to gravity? It is the acceleration by which any object is pulled towards the second object. For example, if I am having Earth, please pay attention. Its mass I am taking as mass of Earth, me. If I am having any other object here and let its mass be m on the Earth, distance between them will be approximately r, that is r means radius of the Earth. The distance between the mass and the center of the Earth is what? Earth's radius. Now, if I want to find what is the attractive force between them, then the answer will be F is equal to G into M into ME by RE square. Do you agree with me? Do you agree with me? And we know that force is equal to mass into acceleration. In this case, I am writing small g as acceleration. I told we will take it as g. So, if I equate these both, equation 1 and equation 2, I come to know that from equation 1 and 2, mg is equal to g m me by re square. This gets cancelled and we are going to get small g is equal to g me by re square. Now, here if I put the value of capital G known to me, how much is that? 6.67 10 to the power minus 11. What is mass of the Earth? 6 into 10 to the power 24 kilograms. What is the Earth's radius? 6,400 kilometers, 10 to the power 3 meters. If I put these values in the equation and solve it, then I am going to get the value as 9.81 meter per second square. That's how we get the acceleration due to gravity of Earth. Same way, if you want to find acceleration due to gravity of any planet, any celestial object, what you have to do? You have to put its mass and you have to put its radius. If I am finding for moon, mass of the moon, r of the moon square, get the answer. Same way, by this formula, I can find acceleration due to gravity of any object. You can even find your own acceleration of gravity. If I put the value of my mass and suppose radius I am taking from my body, then I can find that what is acceleration to gravity of me, which will be very small value. It will be very small value because my mass is very small and is 16 to the power minus 11. So, it will come 0.000000 something like that, negligible. I hope you are getting my point. Any object's acceleration due to gravity can be easily found. If it is clear to you, copy it fast. It is very basic thing which we learn in 9th level itself. Can I proceed further? If yes, give the heading as factors affecting G. Factors affecting G. There are 4 factors. The first factor is shape of the planet, or if I am taking about Earth, shape of the Earth. Second factor is height above the Earth. Third is depth below the Earth. And fourth is rotation of the Earth. So remember that rotation of Earth is not there in school syllabus, it is only there in competitive syllabus. So in Sunday's class alone I will talk about this. This is only for competitive examination, but in regular school examination only these 3 are applicable, that is shape of Earth, height above the Earth and depth below the Earth. Now everybody please pay attention. These things are I think known to you, maybe second and third will be little numerical oriented, but let us learn that. First, shape of the Earth. So what is the shape of the Earth? Ellipse. Ellipse, seriously. You know what is ellipse? Earth looks like this to you. Earth, what Shrish?
Geoid.
Geoid, yeah, that sounds better. So basically, Earth's shape is called as geoidal shape or spheroidal shape. So Earth is geoid. What is the meaning of geoid? Geoid means it is flattened at top and bottom and elongated on the sides, something like orange. How an orange will be? Not ellipse for sure. Orange will be elongated at sides and flattened at top and bottom. I am not drawing the great diagram. Something like this. It means that Earth's radius is not constant. Radius at equator is greater than radius at pole. Are you getting my point? Are you getting why? Because we have bulged sides and flattened top and bottom. That makes radius of the equator to be more than radius of the pole. We know that small g, the formula just now we derived, it is gm by r square, isn't it? If small g is gm by r square, r is going to be more, g is going to be less, because g and r are inversely proportional. It means g at equator is less and g at pole is, or I can say that as we move from equator to pole, g keeps on increasing. Least g we have on equator, maximum g we have on pole. So suppose a person is moving from India and he or she is going to China, then to Russia, then to Arctic circle, I mean that is topmost point, or going down, let us assume like that, from here you are going to Sri Lanka, already we are in Tamil Nadu only. So going to Sri Lanka, going to Malaysia and then going to Antarctica down. So if you are travelling either above or you are travelling below, your g will keep on changing, g will keep on increasing, but not at significantly increase to make you notice that, but it will change. Suppose your mass is 50 kg here in the equator side, it will become 50.0304, like that it will change. Very minimum change in mass, weight, but it will happen. And if you go towards pole, you will have the maximum weight, and if you are at equator, you will have the minimum weight. Is it clear to you? Why is Earth's g changing by shape? Because of the shape is not a perfect sphere. If shape would have been perfect sphere, then every point will have same g. But now we don't have spherical shape of Earth itself, which makes G is different. Copy this up fast. Shall I talk about the height above the Earth now? If shape is clear to you, second we will talk about the height above the Earth. Shall we? Make it fast. Shall we? Yeah. So we'll talk about the height above the Earth. Now please pay attention. On this Earth, if you are standing here, you have some G value. And if you go some H height above the Earth, your G will change. Will it increase or it will decrease? Will your G increase or will it decrease? Increase. It should decrease because it should decrease. Small g is gm by r square, isn't it? R becomes bigger, no? When we are on the surface, this is the value of r. If you go here, it will become r plus h. So at point 1, if I am taking it as point 1 and this I am taking as point 2. So if I am writing at 1, I will come to know that small g is equal to gm by r square. What about at 2? At 2, g dash is equal to what? G into m by r plus h the whole square. It became bigger, isn't it? I hope you are understanding this. So if it became bigger, g must become smaller. So what we come to know from here? As we go above the Earth's surface, small g is reducing. Okay. So how much reducing? We can find that mathematically. So g dash we have, g we have. If I am writing g dash by g, what will happen you see? Gm by r plus h the whole square, and here gm will come and above what will come? R plus h the, sorry, gm by r square it will become. Isn't it? Yes, gm gets cancelled. We are going to get g dash as r by r plus h the whole square into g. Is it clear to you? So by this formula, whenever you want to find the small g value at a particular height, you can easily find by putting the value of h here. Suppose I ask you 1000 km above the Earth, what is the value of small g? What will be the answer? You will put here 6400, here you will put 7400, you will do square of that and multiply by 9.81, you will get the answer. If they ask you what is the value of acceleration due to gravity 2000 km above the Earth, then you will take r as 6400, h as 2000, it means down will become 8400, square of that multiplied by g, you will get the new g dash. Are you getting my point? Copy it first, I will talk further. First you copy this. This is very basic. I will increase the level now. Copied? I hope you have copied. Shall I move further? Please pay attention. We have got the value of g dash as r by r plus h the whole square. What I am doing, you see, I am bringing r in denominator. So, I can write 1 by r plus h by r the whole square into g. I can write like this also. Anyhow, it is going to be going above only. Are you getting what I have done? I have brought this r below. Why I have brought? I will tell you. So, it will become g dash is equal to 1 by 1 plus h by r power 2 into g. Do you agree? 1 square by 1 plus h by r the whole square. I can write this as g dash, this step itself. Okay. I have brought this r below in this denominator. If you ask me how can you bring it? If I am writing 2 by 4 and if I am writing 2 by 4 by 2, that is not 2, 2 comes down, 1 by 4 by 2, they both are same only, no? 2 if you cancel it will become 1 by 2, here also if you cancel it will become 1 by 2 only. That is what I am doing here. So, if I bought r below, then this r that is I am doing it individually. So, r by r will become 1, h by r I have written here. Now, it is 1 square divided by 1 plus h by r the whole square. I am bringing 1 plus h by r in the numerator. It will become 1 plus h by r power minus 2 into g. Do you agree what I have done? Are you agreeing what I have done? Now, it became a binomial expansion. Have you studied binomial theorem in math? Which course only you studied? Not like that. Okay. So, in binomial theorem, this 1 plus x power n can be written as 1 plus nx if x is much less than 1. You will study this in the binomial theorem in math in 11th, it will come. But for now you can remember that. If I am having 1 plus x power n, it can be written as 1 plus nx. Many of the terms will be there, but I can neglect those terms if x is much less than 1. It means in this case, if h is much less than r, if h becomes much less than r, then this whole term will become much less than 1. If you have a very small number by very big number, you will get an answer very smaller than 1. 2 by 100, 0.02. 2 by 1000, 0.0002. Are you getting a point? So, if you have a very big number in denominator and a very small number in numerator, automatically the result is much smaller than 1. Same logic, if I apply here, h being much less than r, I can write g dash as 1 minus 2h by r into g. This is another formula of g dash which we can use if h looks very small than r. For example, if they ask you what is the acceleration due to gravity 100 meter above the earth's surface or 1 kilometer above the earth's surface. Now, 1 kilometer is very small compared to 6,400 kilometer. If you compare 1 kilometer and 6,400 kilometer, I can say h is very smaller than r. I can directly use this formula. No need of using that formula. Are you getting what I am trying to say? This formula is applicable only if h is much less than r. Are you getting my point? So, we have copy this first, then I will talk about further. Copy it fast. Check what I have done, copy it fast. Have you copied it? Make it fast, please. Have you copied? Have you copied? Take the question. One question I will give you now. See, one thing what we have learned from here is, if we are going above the earth's surface, h height above the earth's surface, there are two possibilities of g dash. What is that? G dash can be taken as r by r plus h the whole square into g, or we can also take g dash as 1 minus 2h by r into g, when if h is much less than r. Clear to you? Any of this formula can be used in the numerical based upon what is the condition given. Take one question now. Question is, everybody please copy the question. Question is, what will be the acceleration due to gravity? What will be the acceleration due to gravity? What will be the acceleration due to gravity at a height of 6,400 kilometer, at a height of 6,400 kilometer from the earth's surface, at a height of 6,400 kilometer at the earth, from the earth's surface, 6,400 kilometer from the earth's surface, from the earth surface. Try this question. Lakshita and Shakti Varshini, why is your video off? GS? Just report the answer in terms of G itself. 1 by 4 G. Okay, let me check. Anybody else? Anybody else?
0.25 G.
1 by 4 only he also told. 0.25 G. Okay. Anybody else? Anybody else? Two people have told the same answer. Tarun here and Shrish there. Both have told 0.25 G is the answer. Do you agree with him or you have another answer?
Sir, 2.46.
2545.
No, sir, 2.46.
2.45 G. Okay. Anybody else? Shall I solve it? The question says, Hmm.
Said in terms of G, sir. It said in terms of total. He substituted G.
Okay, let us check. Let us check. So the question is, Earth, its radius is r, and how much away you are going? Same r distance away, isn't it? I'll just simple way of solving this question. You are already at r distance, and same r distance you are going over, because I told what is the value of g at 6,400 kilometers of the Earth's surface. So if you are a smart student, what formula will you use? We cannot use that formula 1 minus 2 h by r, because h and r are almost same, not almost, they are same only. So g dash will become equal to r by r plus r the whole square into g. Do you agree with me? Yes or no? How much will be that? R by 2r square into g. R gets cancelled. So how much you are going to have? 1 by 4 times of g. This is the answer. Over. Yes, 1 by 2 square is 4 only, no? 1 by 2 square is 1 by 4 only, no? Understood, no? So 1 by 4 g is correct. How it came, you understood? Very simple question. Nothing is there in this question. Is it clear to you? Any doubt in this? If I would have asked you, what is the value of acceleration due to gravity at a distance of 12,800 kilometers above the Earth's surface, what will happen? This will become 2r, isn't it? And it will become r by r plus 2r. So r by 3r the whole square. So 1 by 9 times of g will be the answer. Are you getting what I am trying to do? Take another question. Take another question. If an object weighs 72 Newton, if an object weighs 72 Newton, if an object weighs 72 Newton on the Earth's surface, at what height above the Earth's surface will the weight become 32 Newton? At what height above the Earth's surface will the weight become 32 Newton? Will the weight become 32 Newton? Give a try. How it is possible? Height becomes negative means you are going inside the earth. Any answer? Again I am repeating, do not always expect the question to be direct. Sometimes question will be little indirect, you have to think and solve. Shall I solve it or will you solve it?
Sir, 1 minute, sir.
Okay. So, I should solve, right? Nobody has told the answer. Huh. Yes, tell me, man.
So is it 0.5 times the radius of Earth, sir?
I don't know, let me solve and check.
Sir, I got 1.5.
Let me check. So, what is the question saying? Please pay attention, interesting question. They are saying that on the earth, somebody has a weight of how much? 70. If you go at what height, the weight becomes how much? 30? This is the question, isn't it? I hope everybody knows weight means mg, isn't it? So, they are giving mg as 72 Newton here, and here m remains same, mass is constant. So, mg dash is given as how much? 32 Newton. Okay. Now, what is the formula of g dash? G dash is equal to r by r plus h, the whole square into g. I am multiplying both sides by m. Why I am doing so? Because I have the value of mg dash and mg only known to me. So, what will be mg dash? 32. mg I will bring it down. How much will be that? 72 is equal to r by r plus h, the whole square. Do you agree? I will cancel this 2 16 times, 2 36 times, isn't it? So, it will become r by, I do not want to cancel further, r by r plus h becomes equal to, root will go that side, it will become 4 by 6 or 2 by 3, or I get 2 by 3. So, r by r plus h is equal to 2 by 3. I can write 3r is equal to 2r plus 2h, right? Cross multiplying. So, it will become r is equal to 2h, or h becomes equal to, good Shoaib, you are right, h is equal to 0.5 times of r. Manager, what you are saying is correct from center of the earth. From center of the earth becomes 1 r plus 0.5 r, which becomes 2.5 1.5 r. but they are not asking from the center of the earth. I think they are asking from surface of the earth, which will be 0.5 r. Is it clear to everybody? Again, not a tough question. A small change, where they not gave g, they gave weight indirectly. Is it clear to you? If anybody has doubt, ask me. If there is no doubt, please copy it. We'll go to the next concept now. We'll go below the earth now. We will go below the earth. If anybody has any doubt, feel free to ask me.
Sir, what is the answer, sir?
R by 2.
For this?
Were you there in the class, man, when I was telling Shrish?
Yes, sir, I'll answer right. Yes.
Okay, okay. Understood, Shrish, how R by 2 came?
Sir, yes, sir, so we don't need to print exact value.
R by 2 means 6,400 by 2, man. Exact value will be 3,200 kilometer, that's all.
Okay, sir.
Yeah. Shall I proceed further? Okay. So, up to now, what we have understood, if you pay attention, we have understood that small g, which formula is gm by r, general formula is gm by r square. If we go above the earth, h distance above the earth, then g is reducing. Why it is reducing? Because r is increasing. If r increases, g reduces, common sense. Okay. Now my question is, Niharika, think and say, if I am going to go below the earth, from center, now I am going below the earth, suppose I am going here. At this point, whether g is going to increase or it is going to decrease? Decrease. Why? Increase. Okay. Because r is going to decrease, so g is going to increase. Do you agree with her, Tarun? Anu Kirtana? Agree with her? Sadhana? Agree with her? Okay. If I ask the same question to Kirtish Kumar, people are saying that if I go inside the earth, the small g will increase. Why it will increase? Because if I go inside the earth, r will become small, g will become more. Do you agree with them?
Sir.
I think you told yes.
Yes, sir, all the possibility exists, so according to the rule, the G will be increased, sir.
G will increase. Okay, fine.
Yes,
So,
sir.
okay, fine. What about you, Soumya? What is your opinion? Soumya, if you are hearing me. Please unmute yourself. The moment I take your name, you should unmute yourself. Soumya, am I audible? Why is it so late response from you? I asked you what is your opinion. If I go inside the earth, whether g will increase or decrease or remain same? It remains same. Oh, why it remains same, Soumya? Question is, if I go inside the earth, whether the value of acceleration due to gravity going to increase, decrease or remain same? When we went above the earth, g value reduced because r became bigger, g became smaller. When we go inside the earth, r becomes small, so g should become more, isn't it? That's what the common sense says. So, what do you feel? G will increase or decrease? Increase. Kashika, what is your opinion?
Sir, I hope it decreases, sir.
Decreases, you are saying.
Yes, sir.
Why? Tell me, explain why.
Sir, the mass is exerting inside, sir. Like due to gravitational force.
Okay, so
So I hope it decreases, sir.
okay. See, if you tell it is going to increase, it makes some sense, because common sense says that r is going to become small and g is going to become more. So it is common sense, but you are saying something which is not common sense. So definitely I'll ask question to you, and you are giving explanation like, what is the explanation? Once again explain, Karshika.
So I think the mass is like it exerts due to gravity. I hope it decreases when it attracted to the center.
Okay, somewhere you are fine. One thing, if I go below the earth's surface, then the mass in this level also is going to change, right?
Yes, sir.
Have you ever thought about, good Kashika, you thought about that. Moreover, in simple words, if I say, whenever you are going inside the earth's surface, always remember density will play into role. What is the formula of density based upon g? We found before some time, small g is equal to gm by r square, but we did not found the formula of small g based upon density. Can you find it? Yes, you can find it. How we can find it? Density is equal to what by what? Mass by volume. So mass of the earth divided volume will become 4 by 3 pi r cube. So from here I get mass is equal to 4 by 3 pi r cube into density. Am I right? This is the mass formula. If this is the mass formula, then if I put this formula here in this equation, I am going to get small g is equal to g by r square into 4 by 3 pi r cube rho. R square will cancel this, and then you will get small g as 4 by 3 pi r rho g. Now this formula very clearly indicates you that g and r are proportional. Small g and capital R are what? They are proportional. Proportional means if g is going to increase, r is going to increase. If g is going to reduce, r is going to reduce. Come again, yeah.
R square is common for G and M.
R square is common for
G and M.
g and m means, yeah, obviously yes.
Sir, we should put whole power by R square.
That only I did not. What is this? Gm by r square, g by r square. Instead of m, I am writing this value. That is not a point. Are you getting what I am trying to say? Instead of m, I am substituting this. What is the substitution? 4 by 3 pi r cube into rho. So r square will cancel that. Are you getting how I have done? Okay. So small g will become equal to 4 by 3 pi r rho g. It means that if I am there, see, if you are present on the earth's surface, the value of small g is 4 by 3 pi r rho g. Understanding? And if you are going inside the earth, suppose I am going d depth inside the earth, then what is the value of g dash? G dash will become 4 by 3 pi r, what will be this distance? R minus d into rho g. Are you getting my point? When I am on the surface of the earth, if my small g is 4 by 3 pi r rho g, if I am going d distance inside the earth, what is the radius now? It is 4 by 3 pi. What is the radius now? R minus d, isn't it? So as the r is reducing, g will also reduce. If you go above the earth, g reduces. If you go below the earth, g still reduces. And imagine what will happen at center. At the center of the earth, what will be the value of r? R will become 0, isn't it? So what will be g? G will also become 0. It means at center of the earth, we have no gravity. It's like being in space, you will fly. If any day we are able to go to the center of the earth, we will not be having any gravity there. And you know one thing, Are you able to hear me now?
Yes, sir.
Yes, so I was saying that if I go above the earth's surface, I will get weightlessness, like space we fly. If I go in the center of the earth, I get weightlessness, I will fly. In which case I will feel more weightlessness, in the space or the center of the earth? Why you know? Because center of the earth, small g becomes absolutely 0. If you go above the earth, the formula is g is equal to gm by r plus h the whole square. It means that it becomes very big, it becomes very small. Only if it becomes infinite, it will become 0, isn't it? So if you go infinite kilometer away from the earth, only then you will have 0 gravity. Otherwise, some gravity will be there. Since its value became too less, you are not feeling it, but not 0. But if you go inside the earth, at center of the earth, it will be absolute 0 acceleration due to gravity. That is the maximum effect of weightlessness can be felt where? Center of the earth. I hope it is clear to you. So what you learned today? You learned that if you go above the earth's surface, g reduces. Even if I go below the earth's surface, g reduces. Where is the maximum then? On the surface of the earth. At which point? At the pole. So if a question is asked, this I have asked in bridge course also. If there are 4 points, point number A, point number B, point number C and point number D, where is the G maximum? D. G maximum Tambi? A. Why A? Because C is above the earth, less G, D below the earth, less G, A and B are on the earth, and on the earth A is on the pole, so it will have maximum G. Is it clear to you? If it is clear, copy this fast. Whatever I have written on the board, you can copy it in your own way. Whatever I have written on the board, please copy it.
Sir, one doubt, sir.
Ask me please.
Sir, நீங்க வந்து radius வந்து inside இருக்கும்போது t வந்து 0 சொல்றீங்க sir.
Can you be little louder? Sorry, little louder please.
Sir, r வந்து infinite இருக்கும்போது g வந்து 0 ன்னு சொன்னீங்க sir.
ஆமா.
Sir, now Newton's law வந்து every particle in the universe attracts each other சொல்லுது. எப்படி 0 சொல்லலாம்?
See, you are confusing between force of attraction and acceleration due to gravity. I am saying that if there is an object, if suppose one object is here, one object is here, they will have some force of attraction. I am saying that this force of attraction is inversely proportional to square of r, right, Kritish Kumar?
Yes, sir.
It means that if r is going to become big, big and big, f is going to become small, small and small.
Yes, sir.
If r is going to become infinite, f is going to become 0. 1 by infinite is 0. Are you aware about this? 1 by infinite is 0. Are you aware about this, Kritish?
Yes, sir.
Because how it came, if you ask me, because 1 by 0 is infinite. Something by 0 is infinite, it means 1 by infinite is 0. So if distance becomes too large, then r will also become infinite. If r becomes infinite, force becomes 0. If force becomes 0, the acceleration due to gravity also will become 0, Kritish. Purida?
Yes, sir. Yes, sir.
Okay. That's what I R, G also increases, yes, up to surface of the earth only. So don't go above the earth, because above the earth if you go, density will not play any role. Okay? So don't think that, sir, if as per this formula, if R is going to be more, G is going to be more. So if I go above the earth, G should become more, not like that. This formula is applicable only for the depth. Remember that. So have you copied this? Everybody? Let me know if you have copied. Indumati went for dinner. If you are not replying in 5 seconds, it means you have gone for dinner only. Lakshita, what about you?
Sir, my computer was crashing a bit. Sir.
Yeah, that's what will happen. When you want to off the camera, computer will
No,
crash,
sir, no, sir, really, sir.
internet will
Sir,
become
just, I cannot
slow.
hear your voice, sir. It's just glitching a bit right now, too.
Okay. Fine. See, I am here, you are there. I cannot see what you are doing behind the camera, but God is everywhere if you believe God. God sees what you are doing. Okay, fine. Anyhow, I am not promoting any spirituality here, but definitely be honest to yourself, be truthful to yourself, not to others. To others, you can be bad, but be good to yourself at least. Okay? So, always remember that your true identity is not when you are in front of somebody. Your true identity is what you are when nobody is around you. Okay? Coming back to our class. So, we have learned today about gravitation. We came to know what is gravitation, what is gravitational force. We understood Newton's law of gravitation, which relates the mass, distance with force. And as per Newton's law of gravitation, every two object in universe attracts each other with a force that is directly proportional to product of their masses and inversely proportional to square of distance between them. By that we made a formula F is equal to gm1 m2 by r square, where g is called as universal gravitational constant. Its value is 6.67 10 to the power minus 11 kilogram, whatever, Newton square per meter square, whatever it may be. Then we understood what is the meaning of acceleration due to gravity, which is the acceleration by which any object is pulled towards any other object. For Earth, its value is gm by re square. If you put the value of mass of Earth and r of Earth, the value comes 9.81 meter per second square. This value also is not constant everywhere. As you move on the Earth, it changes. So, the factors which affects the value of small g are 4. First factor is called as shape of the Earth, second is height above the Earth, third is depth below the Earth, fourth is rotation of the Earth. Shape of the Earth is not perfect sphere. If it would have been perfect sphere, r is constant, g will become constant. But Earth's shape changes because Earth is a geoid. Geoid means flattened in top and bottom and elongated in the sides, which makes radius of equator more than radius of pole. That's why g of equator is less than g of pole. So, g is maximum at pole, least at equator on the Earth's surface. Same way, if you want to go above the Earth, we found by the formula small g dash is equal to r by r plus h the whole square into g. If h is much less than r, then g dash is equal to 1 minus 2h by r into g, which says that whenever you go above the Earth's surface, g will reduce. Same way, when we go below the Earth's surface, density of Earth starts coming into play, and the value of small g will not be assumed to be gm by r square, rather it is taken as 4 by 3 pi r rho g. So, if you go below the Earth, since r is reducing, g will also reduce. At center of the Earth, g is absolutely 0, and any point below the Earth, what is the value of g dash? We have not made the equation of that itself. So, if you want g dash we know, g we know, make g dash by g. What will happen? G dash is 4 by 3 pi r minus d into rho into g divided by 4 by 3 pi r rho into g. 4 by 3 5, this gets cancelled, rho g gets cancelled. We get g dash by g is equal to what? R minus d by r into, that's all. So, if you want to further write, we can write g dash as 1 minus d by r into g. This is the formula by which you can find this value of small g at d distance below the Earth's surface. This formula will help you to find the value of small g, what? D distance below the Earth surface. That is what we learned today. So, in next class we will talk about the Kepler's laws, very important. We will talk about gravitational potential, gravitational potential energy, and we are going to talk about satellites. That is, what is the diameter of satellites, height of satellite, or all these things, velocity of satellite, escape velocity, orbital velocity, all these things. Okay. Next class is going to be more important than today's class, because today what we learned was basic things. Some of the things already you know from 9th standard. But next class what you are going to learn is going to be completely new to you. It's going to be advanced topics of 11th standard. So please don't miss the next class, and we will meet again on next Thursday. Till then, take care. Bye bye. If you're